Okay guys, today we are going to talk about polar coordinates. And really, if you think about it, polar coordinates are pretty easy. So let's understand there's polar coordinates, but what we normally use are rectangular coordinates. And a rectangular coordinate is just like an x and a y. Okay, so let's think like this. So let me just work an easy one so you understand the concept. If I come here and here, in rectangular coordinates, how would you describe that point? It's the point what?
1, 1.
1, 1, right? That's very, very easy. Okay. How many different ways can you describe that point? Only one, right? It's 1, 1. There's no other way you can describe it. If I say 1, 1, it's very, very clear what I'm talking about, right? Okay. And a lot of problems you just work like this. But some problems are, so that's rectangular coordinates. Some problems are easier to work in polar coordinates. And polar coordinates have two numbers, okay, but it's not 1 and 1. The question is, it's like, how long is the vector? How long is it from here to here? Well, this side is how long?
1.
And this side is how long?
1.
So how long is that one? Yeah, it's okay, you know what we know is a squared plus b squared equal what?
C squared. Okay.
C squared. Okay, and what's a?
1.
1 squared plus
1 squared.
equals c squared. Okay, and there 1 plus 1 is 2 is equal to c squared. So c is equal to what?
C will equal the square root of 2.
Square root of 2. So we know how long is our vector. It's the square root of 2. So the first number is the square root of 2. That's just saying how long it is. Well, if the first number tells me how long it is, what does the second number have to tell me? Yeah, how far is it? Theta, right? The angle. So if you give the radius or the length of the vector and an angle, it's exactly the same thing as saying the x and the y. And so what would this angle be if this side is 1 and this side is 1? Catherine, can you take a shot at telling me what the angle is? This is 1, and this is 1.
No, it'll be 90 degrees.
90 degrees?
Nope, that is not correct. It will be 45.
45 degrees. Okay. So it's the square root of 2 and 45 degrees. All right. I'm going to tell you the way that I like to write it. So like it would be in rectangular, it would be the point 1, 1. In polar, I would describe it as, to make it clear that we're in polar, it's the square root of 2 at an angle of 45. And that way, when you write it that way, it makes it a lot easier to see that you are in polar. Does that make sense?
Yeah.
Okay. So in general, what you can see is the point x, y is rectangular notation, but if you look at it as some radius, some length, theta, that's r at an angle of theta, that is polar. Okay? Is there any questions about that? Okay. Let's just do a couple of easy ones. So like if I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and you want 2 at an angle of pi over 3. How would you do that? You would first come up how much?
2. No, you can have 4.
Yeah, no, just kind of think, what's the angle? Pi over 3. And pi over 3 is like 30 degrees, right? Or what is pi over 3?
Pi over 3 is 60 degrees.
Yeah, it's 60 degrees, I'm sorry. I didn't do that in my head good. So this is pi over 3. And you don't go out to here, right? Because if it's 1, 2, and you go out to here, that's longer than 2. So what you have to make is you have to make this 2. So this is 2 at an angle of pi over 3. Does that make sense, Catherine?
Yes, it is.
Okay. So Catherine, you help me with this one then, so that we just get comfortable with it. So if I have 3 at an angle of minus pi over 6, okay, tell me, Catherine, what the angle minus pi over 6 would be. Just like talk out loud.
It's in quadrant 3, correct?
Let's see, 1, 2, 3,
Isn't it quadrant 4?
4, right? Because
Ooh,
okay.
yeah.
So how far would I come
Yes.
down?
How
many degrees?
Like 30 degrees.
Yeah, 30 degrees. Okay. And then how far out do I go?
To 3.
Okay. Where this is 3, and this is minus pi over 6. But this doesn't come all the way out to here, right? Because if you swung it around, it would be at 3, but then you see it comes in as it goes down. Does that make sense? So just be careful how you graph those. In rectangular coordinates, each point is unique, okay?
Hold on.
Yeah.
I'm sorry, are we supposed to base the vector off the x-axis or the y-axis?
Neither. Okay, the vector length is the vector length. So, like, let's say my vector length is 3, it would come here, okay? But then when I swing it down, what does it do? It makes an arc. And so this is not 3 here, it's not 3 here, it's 3 in the direction of
Excuse the
minus
interruption,
6.
but we have a few people testing today, so would you please rise and join me in the pledges? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one and indivisible. Now for a moment of silence. If you are a senior who needs to take the TSI, please come sign up with Ms. Parker on Friday. We have FCA today. I think it's the last one for the year, and I believe it's being catered by Mary's. Please join us. Angelo Awards will be here tomorrow, May 16th, to fit for letter jackets. Be sure and have your order ready and your money for any patches that you're interested in purchasing. Seniors, you will have baccalaureate practice today at noon. Be at the auditorium at noon. The consent to search forms for prom, which is Saturday night, need to be turned in to Mrs. Shipman or the office as soon as possible. And just a reminder, you need to be at school on Friday if you are planning on attending the prom. I need to see Miranda, Mitzi, Junior, and Leanna Gandar, please. I believe that is all of the announcements. Thank you and have a great Wednesday.
Okay, so one thing is, if you have the point 1, 1, there's only one way to describe it, 1, 1, right? So let's say that I have the point 1, 1, and that's rectangular, all right? And then we said that that in polar would be what? How would we describe that in polar? We said the length is what?
The square root of 2.
Square root of 2 at an angle of what?
45.
Okay, and let's say that that's pi over 4, all right? Is that the only way in polar form to get to this point? Square root of 2 pi over 4. Is that the only way that you can get that to that point? You could go all the way around again, right? So you see you have this or you have what? That. So that would be the square root of 2 at an angle of what? 2 pi plus pi over 4. And what is that? 2 pi is 8 pi over 4. What is this? 9 pi over 4. Did I do that right then?
Yes.
Okay, I don't do head math very well. And then you could add another 2 pi, or you could subtract 2 pi, subtract 2 pi. So there's many different ways that you can get there, all right? So you have to see that there are many different places that are all the same point in polar. So that's something a little bit different. Okay, so let's kind of look at an example of that, of things that are the same. Okay, so let's say this one is, what if we said minus 3 at an angle, or let me just say, what if I wanted minus 3 at an angle of pi over 4? Okay, what would you do first, probably, Ben?
I would find the angle.
Yeah, so it would be like this, that's pi over 4, kind of right along there. So what happens, what does the negative 3 do?
That says it's going in the opposite direction.
Yeah, so it would be like this. So this would be 3. Okay, so what is this point? This point is minus 3 at an angle of pi over 4. All right, and what is that the same as? That's the same as 3, and that would be pi over 4 plus pi at an angle of 5 pi over 4.
Oh,
Does that make sense?
okay.
So I come up to pi over 4, right?
Mhm.
And what does the negative do? I got to go the other direction.
Okay, yes, sir.
And think about it this way, right? This is the number line. Positive 1 goes where? Here. But negative 1 means what? The opposite way. Flipped over. So you see here, this is pi over 4. The negative 3 puts it here.
Mhm.
So minus 3 at pi over 4 is the same as 3 at pi plus pi over 4 is 5 pi over 4.
Okay.
Does that make sense?
Yes.
It could also be 3 at what? Positive 3 at what?
Negative.
Negative. This is pi over 2 plus pi over 4. That would be 5 pi over 4, right?
3 pi.
Would it be?
Because 5 pi over 4 plus 3
Yeah. Minus 3 pi over 4. I told you I can't do head math. 3 at minus 3 pi over 4. Catherine, does this make sense?
Yes, I believe so.
Okay. What we have to do is we have to look, and we want to go 2 things. Polar to rectangular, and we want to go rectangular to polar. Does that make sense?
Yes.
Okay, so let's look. Let's do polar to rectangular. So if I have polar, tell me in generally what the polar coordinates are going to be. In general, it would be, Catherine, can you take a shot at it? If you want to tell me that in polar, I need, the first number is what?
It's going to be like the vector length.
Yeah, what do we call it? It's a letter?
It's
R?
It's not-
Yeah, it's C, right? It's, you're thinking of C, the hypotenuse.
Yes, sir.
It just, in this notation, we call it R, like radius. Okay. And then what do I need? The other one is?
And then you need the angle.
Yeah, and we call that what? Theta. So I have R at an angle of theta. Does that make perfect sense?
Yes, sir.
Okay, so what I need is I need an X value and I need a Y value. Okay, where would the Catherine, can you tell me just in words or just talk out loud, what would the x value of this point be?
It would be how tall it is.
Yeah. Which, no, how,
It would be that. Yes, sir.
no, you draw this, but the x value is where?
Oh, it would be on the x-axis.
Yeah, that's x. And where's y? How tall it is.
Yes, sir.
Okay. And I know what you're saying, you got to draw the line down, but then that gives you, this is the x and that's the y. So Catherine, if this is r and this is theta, can you tell me what x is? X is equal to r times something.
X would be equal.
It's a triangle.
There are a lot of sines or cosines or something.
Do you remember the word we use?
Jason.
Um.
SOHCAHTOA.
Ooh, so-
So r is, x is r cosine theta. Does that ring a bell?
Yes,
Okay.
sir.
So Catherine, what if x is r cosine theta, what is y?
Y would be r sine theta.
Boom, r sine theta. So how hard is it to go from polar to rectangular?
Not hard.
It's very, very easy. In fact, it's very, very easy. All right? So let's do another one. Let's do rectangular to polar. Okay. In that case, how are you going to describe this point? You're going to describe it as what?
X, Y.
X and Y. Okay. Now, what is it that I'm going to need? I have X and Y. What am I going to need? I'm going to need what and what?
You're going to need
Radius and angle.
Radius and angle. Okay. Then, or Catherine, can you take a shot of like, how would I get the radius? Can you just take a shot at what the radius would be? I know X and I know Y and I need the radius.
you're going. I feel like it'd be like x squared, like a squared plus b squared equals
Yes.
c squared.
Okay, a squared plus b squared equals c squared. And what is my c is?
R.
Okay, so that's r squared. And what is my a?
X squared.
X squared plus
Y squared.
y squared. So r is going to be equal to the square root of x squared plus y squared. Is that hard or easy?
Easy.
Okay, now let's think. You said this is x and this is y. I've got to find what now?
Now you need to find. Now you need to use the angle.
Yeah, I got to find the angle. Okay, so theta, remember SOHCAHTOA? Tangent is what? Tangent of theta is what?
Opposite of radius.
And opposite is what?
It's going to be y
Y
over x.
over x. So theta is equal to tan inverse of y over x. Right? Tan inverse of y over x. This is really kind of easy, don't you think? I mean, sort of.
Yes, sir.
Sort of easy. Okay. So let me work a few problems here. Okay. So I want to convert the square root of 3 at an angle of pi over 6 to rectangular. What's the first thing that I should do? Draw a picture?
Mhm.
Okay. So how long is this?
It's going to be the square root of 3. That's not the right direction. No, is that the right direction?
It's positive.
Pi over 6. Oh, yeah, it is positive.
And what's pi over 6? It's about 30 degrees?
Yes, sir.
Okay. So I have this and this, and I want this, x and y. Tell me what x is.
Okay, x is going to be r cosine of theta.
R cosine theta. Always write it down. R is the square root of 3.
And then cosine of pi over 6.
Somebody tell me what the cosine of pi over 6 is. Oh, don't put it in the calculator. Think of the unit circle.
I have no idea.
You don't remember the unit circle?
It's been a long
It's the square root
time.
of 3 over 2, right? Square root of 3 over 2, so this is equal to 3 halves. Okay, and that's why you need to use the unit circle, because you'll get exact answers. So when you're working on the homework, get out the unit
Yes.
circle, and the angle should be on the unit circle. All right, and Benjamin, what is y going to be equal to?
Y is going to be equal to sine
What?
Our sine
of
of theta.
r sine.
R sine of theta,
Yes.
which is equal to the square root of 3, and then what's the sine of theta?
Sine of theta would be 1/2.
So this is the square root of 3 over 2. So x is 3 halves, and y is the square root of 3 over 2. Boom. So we went from polar to rectangular, and then we went rectangular to polar. All right? Okay, so let me give you the homeworks. And what I will do is the homeworks are due Monday, and then what I will do is I will teach more on Friday. Okay. So there's things you can't do all the homework, but do as much homework as you can, and then we'll teach more on Friday. And so do it in 2 different parts. So this is chapter 10, section 7. And the day 1 homework is 6 through 8, 20 through 28, 44 through 52, and the bonus is 128. And then day 2 is 72 through 88, 92 through 100, and the bonus is 134. All right?
Okay, so when will the day 1 homework be?
Well, try to have it Friday,